inside LuaTeX is the standard Lua interpreter. So Lua is an extensible extension language. An extension language because it's a language that extends the semantic on application. So by design, Lua want to extend the semantic of an application by means of Lua scripts. LuaTeX is the main example. Originally, the web, Pascal, and after the C code, has no way to expose the C function on the text side. With the Lua, this C function was exposed to the text side. Lua is also extensible. You can extend the semantic of the Lua language with a simple mechanism. Lua can be extended with a simple instruction required script name. So the standard Lua language has a set of small libraries, but you can build your own Lua libraries and extend the Lua languages with this simple function. Lua can also be extended with dynamic shared objects, DLL or shared object under Unix. But it's not enough just to call the library name. It's not enough. Okay? Let's see, for example, consider this simple C code. There are a couple of functions that practically add some numbers or a reset function. This is quite plain C code that you can compile with this instruction. This is the shared object, the library, okay? And this is the function that our library exports. You can lower this library, which is object code, in Lua in this way. Just this is Lua code. Just lower the library and the function. Okay? Reset, increment A, increment B, sum. This is a snip of code that we use in the swiglib project. You will see. If Lua is not able to load the library, then exit. Otherwise, we can say, okay, I want a Lua function that is called reset. Makes sense. I'm loading the C function reset. Okay? After I have loaded all the function, my library, I just call this Lua function, and then I have the Lua function, the C function inside Lua. This is quite a simple example, but of course you can see here that each C function has no input and no output parameters, so it's quite limited. But you can do many things. For example, you can have a static stack and use all this kind of function to manipulate an internal stack. It's simple, but can be powerful. But of course, what we really want is to don't write thousands or hundreds of code of Lua code to load every function or every symbol of the library. And we also want to exchange data between the library and the interpreter. And it's possible, of course, but we have to write another layer of C code and another shared object another library that acts as a middle layer between our C library and the Lua languages. This is called binding. Okay. To build binding, we must follow some precise rules. These rules are called the Lua Application Programming Interface, or Lua API. A rule says that our binding must export this function, so I can call now the Lua instruction, but also I have to follow the semantic for Lua API. So the semantics of the Lua API say that there are few data types. Number, for example, are floating point number, also integers and floating point number, boolean, string, and generic user data. So a generic application has to make a word to adapt his own data structures with these few data structures. Okay. For example, let's consider this simple function that wants two parameters as input and return the sum of two integers. Okay? Quite simple function. This is the C code of the binding of the intermediate dynamic shared object. We can see here that I have to call the Lua API function, and I have to check, to make some checks that the input arguments are correct, and in the end I call my C function here. This is a first part of code that is needed. It's not easy to understand immediately, okay? Then I register my C function with this name, and in this main entry point of the library I put all this library, in this case just one, into with this I register this function with this name. Okay, and then I can call my library with without list all the function as we have seen before, and then I can call the C function here. You can see with two numbers the result is okay. If put one string, one Lua string, I have an error, it's okay. If I put two floating point, I have no errors, and I got the result. Okay? So this kind of, there is a, this probably someone said, okay, this is an error. It should be an error, not a zero. Okay? So, we have seen the binding of just one simple function. But what about if I have a library with hundreds of symbols, hundreds of functions, hundreds of structures? Also, this is, for example, is valid only for GCC. Makes no sense for the Microsoft compiler. So I have also this problem of different operating systems. I also would like to produce a kind of binding robust. And sometimes I also have a problem that some dynamic shared objects are not written in C. So this is called for an automatic binding generators. Binding generator is a program that take the C source, make some analysis, and then produce the C code of the wrapper, of the binding, say. This is a quite wide solution. But quite important problem is how to manage a library not written in C code. The first solution, okay, done. Don't use this library, or better, build a C layer on the top of this library. So I will consider only C library. Because also with the C languages there are some aspects that are not defined, so are still hard to cover with the scripting languages, even if Lua is quite powerful from this point of view. So basically we will use automatic binding generators only for library written in C. Okay, one of this automatic binding generator is Swig, which is quite old program, maybe 10 years or something. And it's very known because it can produce binding for Lua, Perl, Python, SQL, Ruby, Gaia, Java. And it's a strong community. It can manage C and C++ also, but it's better to use C, because C++ is very complicated language. And I feel good with Swig because it's okay, because it's particularly well suited for software development in the small and quick. This kind of program can show quickly the problems of the library, and you quickly can decide to not build a binding, because if the interface is complicated, then probably the project is not so mature for the binding. So, what is the swiglib project? It's a set of binding for LuaTeX, not for Lua, but for LuaTeX. LuaTeX means a wide operating system, CPU target. We have Windows, we have Linux, we have OpenSolaris, we have ST. Okay, so we need a library that potentially can go in many systems. Swig wants an interface file which is almost a C header file, which is clear to understand if you programming in C. Also, the Swig project publishes some simple scripts, bash scripts, 10 lines, on how to build the DLL or the shared object, and is one-to-one with the C library. So if you have the documentation of the library, then you have no problem to program with Lua, with a Lua binding. Okay, one-to-one. If you see the documentation of the library, then almost you can translate it in the Lua scripts. And it's published Superlag at this address. Actually, there is the subversion repository. So let's consider, for example, the binding for the graphics magic library, which is a fork of ImageMagick, and which is a quite stable library, it's robust, it's available for Windows, Mac, Linux, and so it's also well documented. I think about 200 functions, so a manual binding is not possible. Let's see this interface file. This is the file that Swig uses to produce the binding. Here I declare the name by designing the name of the binding is core. Here I include the header. I only make the binding for this subset of magic, graphics magic, because graphics magic has a binding for C++, but I don't want C++ as a binding for C low level. This is a middle level. Is okay. We define quantum depth for our images. So it is 16 bits for channel. This is our Swig function, also like this. Practically sometimes it happens that the library is very old and there are some compromise from years. And it's better to don't modify the original source, but translate some name as in this situation into this one. With Swig you can manipulate the input without modifying the input header file to produce a binding that is better. For example, there are some functions that are deprecated, and I decide by design I don't export to the binding that deprecated function. So I can say to Swig, okay, when you see this symbol, just ignore it, and the binding will be now available. Or for example, I have a problem to build a bind for function with whitelist arguments, because every operating system has its way to manage whitelist data type. So I also ignore this one. Now, the most important part is that all these lines say, okay, just read the header and produce the binding. And this is the last file of the interface file where I say, okay, this is my code. I can eventually use this code to build some particular match. Normally, these are empty. Okay, this is how I build the sharded object. It's with the Swig, I tell to with this line, I tell to Swig to build a Lua interface file from the core file. I compile the file. This is the source of the wrap, and this is the sharded object. As you see, I require some library from the system. This is the library that comes with graphics magic, and this is the library from the system. So I don't provide all the library. I presume that some libraries are already in this situation, for Linux, already present in the system. Okay, this is a quick Lua example. Practically, I create an image of this dimension with the background red. Then I load this TrueType font and write the context. I load the technical explorer, OpenType, and I load this one, so the type 1 fonts. And this is the result. as you can see. There is some difference on the rendering. And this is also the example and the proceeding, maybe.
Yes.
Yes. Okay. Another library, ZMQ, which is ZMQ is an high-level socket library, C library that you can use Windows, Mac OS, Linux. You can write kind of concurrent application, message passing, and so this is the interface file, 10 lines. So not always the interface file is complicated. Sometimes it's very simple. Just include the headers, and you're okay. This is quite good library, of course. Okay, it's important to make a note. This kind of binding is clear if you develop C. But if you are an end user, then very likely you need another Lua layer, as we have done with context, that exposes this functionality to the end user. Okay, so you can, the binding is can be used with the LuaTeX, but maybe LuaTeX need another Lua layer, as we have done with context. Okay. Given that it is a tech project, the swiglib have to make some requirements. For example, how to choose an interesting library. From a point of view, the API must be stable. It must be well designed and is C language based. After this, I have no other requirements, but there are not many libraries are API stable or well designed. So we must deploy this file for the operating system CPU that are used also by LuaTeX. So we have also the problem on how to deploy these files, because of course a shared object doesn't work on the Windows, and DLL doesn't work on the Linux, for example. So I have started to make some experiments, and actually I'm using Linux with Ubuntu and Windows with the WinJW cross-compiler or YNA emulated compiler. I also made some tests with Microsoft Visual Studio, which is okay, because usually the binding, the C source code of the binding is quite portable C code, so it's not a problem. And also I have done some binding for Luigi Scarso. Also, they also works. So I'm pretty confident that compiling the binding is not a big issue. The problem is how to deploy this shared object in a portable manner. After we have made some experiment, in the end we have chosen to put all the shared objects into this kind of directory. This depends on your system. This is part of the text, but this is standard. So it's not necessary to register the library in some other manner. Just put the library into this one, and it works on the context and for Windows and for Linux. Okay, this is, for example, how I deploy the graphic magic. You can see these files, the version repository, the interface files, the shared object. These are this one. Okay, these are the files provided by the graphics magics, and sometimes also necessary to provide this library. Can be necessary to provide other library because graphic magic uses LibGang 15 and LuaTeX uses LibGang 16. So I use the same LibGang of LuaTeX here. Okay, this is the current status. I think you can call it alpha status because it's oriented to developer. I have done this kind of binding for C URL, graphic magics, Nipers library with something after MySQL, QPDF, which is a C++ library, this one, the C++ library with a C layer. QPDF, I have my binding for QPDF for you.
Yeah, somewhere.
It's a library for post-processing PDF file, web optimization, with encryption, something similar, and zero MQ. They need the test course. The next step for the next content meeting is to produce some kind of documentation and example. And also works with this module. This binding is an help to interface Lua with C, especially for the card pointers that are quite hard to manage. I have still to fix something. And okay, that's all. That's all.
We've got some time for questions.
Yes,
Comments? Yes, please.
Using this, de facto we can call and execute from text source and a binary.
You have two ways to
Near automatically.
you have two ways to call executable dynamic shared object. You can spawn a process.
Yes, but this can be, as I understood, automated.
Yes, both way. You can spawn a process. When you spawn a process, you execute the process, then you have a high startup time. Okay.
Okay. But
this is
it is possible to run binary code automatically from text source.
Yes, yes, it's possible.
This is danger.
It is already possible.
It's already possible.
It's already possible for 15 years, I think. So.
Yes, it was already possible from the beginning because you can call a process. And now
I remember
it's also possible with this mechanism where you don't.
18 and I remember this, but this method, as for now, was complicated.
Well,
But this method gives chance to execute any code from shared object. Near automatical. This is danger. How of security? This code can be Trojan, virus.
Yes, every plugin mechanism solves the problem of speed and opens the problem of security.
Yes.
Yeah.
So
no, but that actually.
So for security, we need to.
We Careful.
solution for the security. Yes?
It is already possible in the current LuaTeX to say that you don't want to enable any lib or anything.
Yes.
It's already possible.
Yes.
So you can run LuaTeX in a mode that is pretty stupid, cannot do anything with that kind of stuff, and then you are safe.
Exactly. If you want security, just don't run external process. If you permit to run external process, then you have a...
But how if this who decided about running this external process is not me?
No, actually you're mistaken about security of text without libraries. You sent me a couple of articles, I think, that you found about how to write 60 ways how to write a virus that destroys your computer in just plain LaTeX. And I think there are 2 articles on the web of research projects that if you look at them you say, okay, you can just lose.
But for now there is no problem.
Yeah, there is a
Problem will be when will be created Trojans or backdoors.
You can already do
Or
it.
backdoors which create, for example, using some scripts, automate connection binary code to textures.
You can already do that.
Sorry, you can already do that, yes, as Hans points out, and there is no way out of this. I mean, you have to be careful what you are running, and you have to inspect your code and don't accept code coming in from somewhere else without looking into it. Now that's the point.
If we talk about security, be careful is not solution.
Well, you don't use it then. There's no way
I
out.
hide yourself in the cellar and then...
Michał?
Do you also release these bindings to use with only Lua?
you can use it
Like Lua.
only with Lua.
Aha, okay. So you can download and load
Experiment.
Yes.
Okay.
You can run LuaTeX. If you run it with minus Lua only, it's just a Lua interpreter.
Exactly.
More concerns, comments? Yes?
The most not dangerous but hard element of this is multi-platform, multi-operating systems. I have some library with connected with Lua, and there is so much problems with conversion in file system with
Yes, this is true. This is
some construction.
This is why we have chosen
Two only.
you have this kind of problem, for example, with Windows, that the DLL can be, you can put all the DLL under this folder. For example, you are safe. You don't need to install the DLL in the system.
Yes.
And for Linux, we actually using the same solution. You just put all the DLL inside this folder, and you are safe. So,
But
it is an
In
option.
fact, okay.
what's your point?
This one, the thing is, that's why this is you can say the other way around. Why don't we use standard Lua libraries? Well, because it is a problem. So this will be part of the code generation of text distribution. Yeah, so if you have the next step live, you get also the infrastructure to generate libraries that fit to that live version, whatever.
Yes.
There's another thing there. If you take, for instance, MySQL, then there would be swiglib, MySQL, and then you have a problem because there are so many versions. So actually there's also a version system there. And what we provide is we have generic loaders with a special command that says load swiglib whatever. That will handle all that for you. We will try to make it as robust as possible. He was jumping over it a bit, but we have spent months on checking which would work out well, which is the way to organize
As
this,
we
how to deal with
chain
different
of
problems. Yeah. It's
PNG is one, and some libraries use dynamically other libraries.
so there will be static bindings and things like that. Really, the project is actually mostly about.
You see how much libraries is loaded.
This switch,
No. in the libs in the compiler.
Yeah.
Free type, JPEG libraries, XML libraries, and we see all of them must be compatible in the system with the
Yes, yes,
this one you linked.
yes. This is why I, the subversion repository, I have the version of the library used. The version needs some specific version of the library. But I use this compiler switch. This is a switch for the linker that say, okay, use the library inside the path where you load this one. Okay, so if you put all the library inside here, then all the references will be resolved before starting from here. Okay?
The problem is not with the SwigLib project. The problem is if a distributor
Yeah.
decides to use and enforce usage of library on the system.
Yes.
Now, what we have said in the project is we provide a reference implementation that works. If a distributor really wants to use the operating system libraries, it's his or her responsibility to make sure that the stuff keeps working. We are not going to bother about that.
Exactly.
So if, what Luigi showed with libpng, we have the problem,
Yes.
if the operating system shipped with libpng 12, it's their problem to make it work. That's not a problem. We provide the system that works. If they mess around, it's their problem. You have to stop somewhere, yeah?
Yes,
Divide the responsibility.
Yeah.
Okay, thank you very much.